Let's look at this example, 3 boxes in a cradle. We have used this previously, but what happens if we turn things 90 degrees and start to have gravity working with us? How do we include this in tolerance stacks?
So according to our simple tolerance stack, the boxes should fit right into the cradle here. But let's see what happens when we try. You can clearly see that the boxes don't fit into the cradle. So let's jump into RD8 to see how to handle this.
All right, so what do we see here? That's a stack-up analysis of the 3 boxes.
Yeah, so this is the simple case that I talked about before, where you see that the analysis passes. And here you only have the simple dimensions of the inner width of the cradle, and then you have the height of the boxes. And in this case, you see it passes, you have sufficient clearance.
Okay, so how much is that? So the nominal clearance is 0.8. What are the worst cases?
Yeah, so it's a span because of the tolerances, so it will be between 0.3 and 1.3 millimeters, the gap at the top.
Up here. Okay, and then what happens then? How do we apply the deflection from a given load if we want to include that in the stack?
So this is what you see in the next calculation sheet I have here. So you have the same formula as before. You have the inner and outer widths of the boxes and the cradle, but now we added the deflection. You have a lot of measures here, and that's because the deflection of taken from an analytical expression.
It looks a little bit more sophisticated, I would say. Yeah.
So yeah, the reason it does is that I've made an analytical calculation here, assuming that the frame acts like a beam being deflected. Then you can input the parameters such as the thickness of the beam, the placement of the load, and so forth. And from this you can see that the analysis will fail.
And I guess also you need to know something about the material properties. So I guess that we have assumed that it's not steel.
Yes, exactly. So this is a 3D printed plastic. So we just put in the stiffness, the Young's modulus that we know from the material. And you can also define the mass of the load all directly in the platform.
Smart. So if you don't want to go the analytical way, is there different ways to then estimate the deflection from a load?
Yes, so this was a simple example where you can assume that it acts like a beam, but you could also have a simulation, like a finite element simulation. Here I've taken the deflection directly from the software we use for calculating or for doing simulations, and then I just take this as a parameter and input to the formula.
So you put it into the simulation software, and then you apply the load that corresponds to the weight of the box here, and then you can read the deflection up there.
Exactly. Then I get a deflection, the parameter E here, and then I just define it directly in my calculation sheet.
And how much is that then? That's 0.75 millimeters. So this is a very classic textbook example. Do we see any of these challenges in everyday life when we're looking out there in product design?
Yeah, so neglecting the deflections is a common pitfall when doing tolerance stacks. So this was a simple example where you have weight as a force input, but you could also have springs, it could be user input, it could be accelerations, it could be many different things. But an example from industry that we know is gaskets, which is pretty common, but you can also see this in your own kitchen. You have this lunch box where you have the box and the lid, and in the lid you have a gasket all around. And what you see is that the gasket will try to force up the lid. So when you snap down to these arms, you'll actually see quite a deflection of the lid.
So like that?
And if you neglected the deflection in your tolerance stack analysis, you would just come to the conclusion that the gap all around would be the same, and it would seem unnecessary to add any additional features.
So it's like this box with the 3 boxes in the cradle. It seems like there's sufficient clearance or compression, but I guess that we are seeing the same kind of beam calculations in play here, that we will actually have less compression of the gasket out here. So
exactly.
That's probably why they added a few more.
Exactly. They did the calculation right.
Yeah. Thank you, Hjalte, for these great examples. hope that you thought that the information was useful, and hope that you will always have a reminder to yourself to think about if there's any loads impacting your tolerance stacks and include these considerations when you're doing design. So good luck with your stacks. See you guys in the next video.